Welcome friends. So in today's video we will be working on project number 14, that is Parkinson's disease detection, and we will be using SVM algorithm. So before beginning, let's talk about what is Parkinson's disease. So it is a brain disorder that causes movement problem, mental health issue and sleep problem, and generally it is a genetic disease. So talking about the data set, we will be using Parkinson's disease data set that is provided by Kaggle, and we have to predict the status whether a person is suffering from Parkinson's disease or not. So we have a status column here. 0 means healthy and 1 means that a person is suffering from Parkinson's disease. And these all are the other parameters that will be used to classify a person. Okay, now coming back to our project, I have already uploaded the Parkinson's data set. You can just download it from here. I will be providing the link in the comment section. Now let's first import all the libraries. Import numpy as mp, import pandas as pd from sklearn dot model selection, import train test split from sklearn dot matrix, import accuracy score from sklearn, import SVM, import, then we have to import standard scaler. So from sklearn dot preprocessing, import standard scaler. So let's talk about all of these. So first one is the numpy that is used to deal with arrays. The second one is the pandas that is used to convert our data set into pandas data structure. Then we have a train test split that is used to split our data into training and test data. Then we have accuracy score, which will be used uh, to analyze our model's accuracy. Then we have SVM that will be used to train our model, so it is an algorithm. Then we have standard scaler. It is used to put all the data points into the same scale. So I will be talking about this later. So first let me just run this. Nice. So first we will load the dataset into data frame, so into pandas data frame. So we have Parkinson's data, Parkinson's data, Parkinson's data. Oh, I think that spelling is incorrect. It's small d. Okay. Now we will print the first 5 rows. Parkinson's data dot head. So we have the first 5 rows, and we have to predict the status. And statuses are target column. Whereas status is the target column. Now let's print number of rows and columns. So Parkinson's data.shape. So there are a total of 195 rows and 24 columns. Now let's see for any missing values. Parkinson's data dot is null dot sum. So our data does not have any null values. That is great. And moreover, I can also see that we don't have any text form of data. That is also good. That and we also do not require a name that we will eliminate in later process. Let's talk about some statistical measures about the data. So Parkinson's data dot describe. So it will tell all the statistical measure, like the mean of the first column MDVP is 154 and 25% of the value of the first column is less than 117.57 and 50% of the value is less than 148.79 and 75% of the value is less than 182.769 and so on, where minimum value is 260 and maximum value is 268, whereas minimum value is 88.33. That is great. So you can study all this for the other columns as well. So moving further on, what we can do, we can see the distribution of the status column, and how many of them are zeros and how many of them are ones. So okay, so what we can do, Parkinson's data, we have to find the status distribution of status dot value count dot value counts here. So 147 of the 147 records have the status 1, whereas 48 records have the status 0. So let me type 1 means, let's type 1 means Parkinson's positive, and 0 means Parkinson's negative. Okay, so now what we can do, first we need to drop the name because it will not add any value to our model in training our model. So let's drop it first. So Parkinson's data is equals to Parkinson's data dot drop, and we have to drop name with the access as column, so it is 1. So let's now we will find the mean. We will group the data based on the target variable. So what we can do, Parkinson's data dot group by status dot mean. So we can see that there is a significant difference between 0 and 1 in the first after analyzing the first column. Same goes with the other columns as well. So our model can easily differentiate between a person as Parkinson's disease or a healthy person. Okay, so we will split the data into features and target. So target is the output column, that is the status. So x is equals to Parkinson's data dot drop column. Yeah, so we x has all the column except the target column, that is status, and y has all the status column. Let's print and x and y just to check. Yeah, so y has all the target column 1 0 1 0 1 0, and x has the features column. Okay, now what we can do, we can split our data splitting data into training and test data. So x train, x test, y train, y test is equals to train test split. We'll provide both the records. Then we have test size of 0.1, random versus 2. Now print x dot shape, x train dot shape, x test dot shape. So initially we had 195 records, but after splitting to train and test, train has 156 records and test has 39 records. Now we will do data standardization. So data standardization. Okay, scalar is equal to standard scalar. Then scalar dot fit. We have xtrain. So let me explain what I'm doing here. So as we can see in this data, we have 119, we have 157, we have 74, then 0.00784. So these are on these all data points are on the different scale. These are on the 100 scale, these are on the 100 scale, these are on the from 100 scale, then this is on the 0.0078. This is on a different scale. So all the columns are in a different scale, so it will be quite difficult for our model to draw a line so that it can classify the target columns. So what we do, we put all these data points into the same scale, so we use standard scalar for this. Okay, so what I did, I initialized the scalar object, then I use scalar.fit so that our scalar can analyze all the data points and fit it into the same scale. Now after the model has successfully fitted all the data points, now what I can do, xtrain is equals to, I will transform the data and the data is xtrain, and similarly I will do it for test. So our data has transformed. Now let me print xtrain. So we can see that initially we have the values as like in hundreds, and then 0.00 something, then something. So they're on the different scale. After transforming, we have all the data points on the same scale: 0.6, 0.02, 0.8, 0.9, 0.5. So these are on the same scale. So now our model can uh, analyze it and classify easily. Now we will do model training. using SVM. So model is equals to SVM dot svc. We have kernel as linear. Then we have, okay, what it says, SVM, it's SV. Then we have model dot fit. We are training our model, so xtrain dot comma ytrain. So model has been trained. Now we will predict the accuracy score. Not predict, we will find the accuracy score on training data, the data which we use to train our model. So first we'll predict the value, then we will find the accuracy score. So we predicted all the values, and all the values are here in the xtrain prediction. Then we will match our predictions using the ytrain that has all the correct outputs with the prediction. So let's print what the prediction. Print training data accuracy. So our model is 88.46% accurate. So let me just print xtrain so you can notice what the output is. Xtrain, so it will contain all the zeros and ones. You can, yeah. So we have our model is predicted as first record as 1, same goes second, and so on. So what we did, we are matching the values of ytrain and our prediction. So as our answer matches, so our prediction is correct, and that's how the accuracy is calculated. Now after doing this, we can go for test data. Accuracy score on test data, x test prediction. So our model is 87.17% accurate. So any accuracy above 70% is considered as good. Now we will build predictive system. First we find the input data. I will leave it first. Okay, now I will convert as numpy array. So input data, so input data as numpy array, input data and reshaped. If prediction of 0 is coming out to be 0, then print the person does not have Parkinson disease as Parkinson disease. Yeah. So for input data, let's take the input from this. Let's take the first. Let's open it with Notepad. So what we need, we have name, MTOP. Let's take it from here, from 119. Control C and Control V. And also we do not require the status, so let me just remove the status. After removing, so our answer is, what was the answer? Answer was 1, so it should predict as 1. So that person has Parkinson's data. So our answer is correct. Let me just print the prediction as well. Print prediction. So prediction is coming out as 1, and our answer should be 1. So our model is working fine. So what I did, first we have the input data. So it is a sample input data. You can take any record you want. Then I converted it as numpy array, because we need array so that our model can analyze it and predict the answer. Then I reshaped the data, because we are predicting it for the one row only. Then I use standard scaler to encode all the data into the same scale. Then our model predicted the uh, data, that is standardized data, and then I printed the prediction. And after that, it's a simple if and else. So that's all for now, and if you have any query regarding this, just do let me know in the comments, and don't forget to like and subscribe. Thank you.